can see those three keywords are interrelated when you are conducting exercise training or competition. Okay. The reason I said this is one of the most important topics is based on if you don't have enough water, then you cannot survive. Okay, if you don't have carbohydrate, protein, and fat, you can still survive for a long period, at least 1 month, right? But if you don't have water, for 3 days, you cannot survive. And therefore, you should consider water or rehydration topic is one of the most important topics in sports nutrition. Okay, and you also understand that during sports competition, the metabolic system is elevated because of the ADP concentration increase. Okay, the ATP concentration is dropping, and the ADP concentration is increasing, and therefore the ADP is going to turn on the metabolic machinery inside the cell, and therefore you are going to have the increased oxygen consumption, and you are going to burn a lot of fuels, including fat and carbohydrate. Another condition is that happen during exercise is some of the cell, especially for the unhealthy cell, is going to die, and it would trigger cell turnover. Okay, the cell turnover process is called inflammation. So you all understand that when inflammation is temporarily increased, you can also increase the heat, right? So that is the condition. You're going to have the heat, right, during exercise, especially when you exercise for a long time. So we have two conditions that is causing fatigue during prolonged exercise. The first condition is called hyperthermia. Okay, hyperthermia is elevated core temperature. We call hyperthermia. And when hyperthermia is occurred, we start to have a dehydration, loss of water. So why we are losing water? It's very simple, because the most important mechanism to dissipate heat is sweating, right? So when the body temperature elevated, you are sweating and you evaporate water away from your body. And this process is going to taking away heat from your body, and therefore you can maintain your body temperature. So there are two conditions that is occurring: hyperthermia and dehydration. And these two conditions are the major cause of fatigue during prolonged exercise. Okay. So if you look at most of the dehydration literature, if you are taking drink, okay, if you are taking drink like this, ice stirring, or you cool yourself by neck cooling. So you put a device on your neck, or you put cold pack on your palm, or you're cooling some part of your body. And this has been already demonstrated that the sports performance will be improved. So there are so many studies right here. From here to here, all studies indicate if you cool yourself, then your performance is going to increase. Okay, if you look at this is the middle line represent if you do cooling strategy, no change in your performance. So if you have the cooling, okay, if you have cooling, the mean is going to shift to the left. So that means the cooling process is going to improve your endurance performance. Okay, so you can see this is one of the major topic, especially for the prolonged exercise. Okay, that's temporarily take away exercise off the table. And you want to know some of the fundamental knowledge about the heat loss. Okay, so everybody know the core temperature in your body is ranging from 61 degree to 72, 36.1 degree to 37.2 degree Celsius. Okay, that is the normal range for most of the people. Okay, so if you if what kind of environment is most comfortable for people if you don't wear clothes? It's between 20 to 25 degrees. Okay, so if you are sleeping, and these are the best temperature range for you to sleep. Okay, so what does it mean? Your body temperature is 36 to 37, and this is the most comfortable in body, the ambient temperature for you to stay. So what does it mean?
Cooling.
Yes, you are cooling yourself all the time, right? Every second you are cooling yourself. So you want to consider human body as a metabolic machine that is always turned on and never turned off. Okay, it's like a car. If you turn on the car and you never just let it on for 24 hours, and the car is going to dissipate the heat as the fuel is burning, right? The human body is never stopped, right? So you see the heat is dissipating all the time. Okay, and therefore the maintaining core body temperature is essential for survival. And the main reason is because most of the protein, so you already learned biochemistry that a lot of enzyme is made by protein, right? And you understand that when temperature change, the structure of protein change. And all those enzymes, they cannot function properly. And therefore, the metabolic system cannot operate. So the body temperature maintenance is considered very important for your survival. Okay. And as you know, the temperature of the surrounding can vary widely, right? So we have 4 seasons. Some of the seasons are very cold, some of the seasons are very hot, right? But you are maintaining your body temperature strictly, simply because you want to prevent the protein structure change. Okay? So the intrinsic thermoregulatory mechanisms are responsible for the adaptability and survival. Okay, so the environment for human, most of the human are operating between 13 degrees to 54 degrees. If you go to the Middle East, sometimes you see temperature like 50 to more than 50 degrees. In India, in Middle East, you can see this kind of temperature. And if you go to North America or Europe, 13 degrees is very common, right? So it's a big range, but your body temperature is maintained in a strict range. Okay. Then let's talk about how do you dissipate your heat to regulate your body temperature. There are 3 ways. convection, evaporation, and radiation. Okay, so during exercise, so this is what happened. So you have sun, and the sun is going to irradiate the light into your body, and therefore you feel hot, right? And the air also absorbs some of the temperature from the sun. And you get hot when your skin directly exposed to the air. Okay? And therefore the environment is very important for you to adjust your body temperature. And you have several ways to dissipate your heat. One is evaporation. So evaporation can be from your tongue and from your skin, right? We call sweating, right? And you have convection and you have conduction. And when you are running, you have increased energy metabolism, and therefore your body heat needs to be released. Right? So during exercise, you feel thirsty sometimes, and that is because you need water. You need to rehydrate yourself. Otherwise, you cannot evaporate. Okay? And you have three ways: evaporation, convection, and evaporation. The most important mechanism to release your heat is evaporation from your skin. Okay? So the curls are very important for you, because sometimes if the curls is blocking the dissipation of the heat, then you feel hot, right? So the curls are very important. And also, water are very important. You want to keep the water inside your body, okay? And therefore you can evaporate. So evaporation is actually, where's the water from? Where's the sweating water? Where's the sweat from? Plasma, right? So you have plasma in your body, and the plasma is when your body temperature is elevating, then the water evaporate will bring heat away from your body, and therefore the surrounding temperature increase. Okay, the air right next to your skin is going to increase temperature, right? The temperature increase right beside your skin, and the body temperature is dropping as you evaporate, right? Because the water is carry energy away from your body. So that is the major way to cool yourself, to release the heat from your body. So this is human. How about other animals? How do you evaporate heat? You have a lot of hair on dog, right? So what is the best way? What is the main mechanism for dog? When dog is running, the energy metabolism also increase, right? So how do you evaporate your heat? It's mainly from panting, right? So that is the major way. So dog and human are different. I would like to show you what is the interrelationship in your of tissues in your body during prolonged exercise. You already know that prolonged exercise is going to elevate energy metabolism, and therefore the body temperature must be increased. Okay. So the muscle, the core temperature of the muscle is going to be increased during prolonged exercise. Okay? And how do you bring heat away? And that's one question. Do you think the brain temperature is also increasing? do you think the metabolism, energy metabolism in the brain is increasing during exercise? The answer is yes. Okay, so you have two major organs require heat loss. Okay, so they are competing for water. The water is coming from blood, right? And the skin also requires water because evaporation obviously needs to bring heat to the skin for evaporation, right? So during exercise, you have such kind of competition between brain, skin, and muscle, right? So exercise not only pulling the blood into your muscle and into your brain, but also bringing water to skin. Okay, so what is the consequences of this? If all fluid is going to brain, muscle, and skin, then how is the heart to maintain the output of the oxygen? You understand that during exercise, the muscle, brain, and skin is going to have the increased energy metabolism. And that obviously demands oxygen, right? And how do you carry oxygen to all these three organs? It's by heart, right? So heart is right next to the lung and bringing oxygen to the rest part of your body. How do you increase? How do you do this? The heart is beating, right? And during exercise, the heartbeat increases, right? And when heartbeat increases, the rate of oxygen delivery will match the energy consumption for the rest part of your body, right? So the cost of the heart is increasing. When you have severe competition between brain, skin, and muscle. So what I'm saying is, if you have a lot of blood, it's pulling to brain, skin, and muscle. How do you compensate to make every single cell in the body has sufficient oxygen? You have to increase the heart rate, right? Okay. So this is the core temperature. Rectal temperature is one of the way to measure your core temperature. Okay. If you look at this is body mass loss from 4% or 3.1 kilogram. Okay. So you are losing water. Okay. When you are losing water, your core temperature is going to increase during prolonged exercise, right? So if you exercise for 120 minutes for 2 hours, then if you have dehydration here, from here, 0.2% of your body weight, all the way to 4.2% of your body weight. And you can see during exercise, under resting condition, not much change, not much difference in core temperature, right? But at the end of the 2 hours exercise, the core temperature is going to rise. And when you have the high degree of dehydration, the core temperature is going to be higher, right? And if you look at heart rate, it's a big difference when you have different degree of dehydration, right? So which one has the severe when you have severe dehydration, the red dot is 4.2% body mass loss. Your body weight is losing water by 4.2%. Okay. Then the heart rate is going to rise to 165. The heart rate is going to be 165, right? If you are well hydrated, okay, you have only 0.2% the water loss, then the heart rate is only 145 to 150. So the difference in the heartbeat can range from 15 to 20, right? So this also gives you a very important hint that if you don't rehydrate yourself well enough, then the cause is going to be on your heart, right? If the heartbeat is not enough, it's not fast enough, the oxygen demand for rest part of your body is not going to be enough, and therefore you can no longer persist your exercise. So this is what happens during exercise. If you don't have enough hydration. Okay. And what is the difference in the core body temperature? Look at here. The well hydrated group and the dehydrated group. The core temperature is only 1 degree, right? So the 1 degree difference in body temperature can cause you a lot of effort for your heart. The heart rate is making about 15 to 20 beats per minute higher, right? Okay, so that is the number you want to know. Okay, so then the question is, let's say you are under resting condition. Okay, so we are sitting here and we are not exercising, but the temperature is increasing. So let's say we turn on the heater here. Okay. So two conditions. One is we elevate the environmental temperature, and another way is we don't elevate the temperature, but we make you dehydrated. Okay, under both two conditions, dehydration and hyperthermia. Okay. Then under this condition, that's the first question. Under hyperthermia, who get the priority of blood? If you are not exercising, okay? So you are under sedentary condition, and we just simply increase the environmental temperature, okay?
Rain.
Yes, rain is going to get. No, actually, we thought it's brain, right? But it's not brain. Who? Yes, skin get the priority. Okay, but if we are dehydrating, then you are correct. Okay, so when we have less fluid, then the brain blood flow is going to increase. Okay, but if you control your fluid and you simply just increase the temperature of the environment, then skin get the priority. So this has been answered before by the experiment. Okay, so the answer is dehydration without hypothermia, cerebral blood flow, the brain blood flow increased by 29%. Okay, so that's dehydration condition. Okay, but if you increase the body temperature, hypothermia, then it's right opposite. You have the decrease of cerebral blood flow by 15%. Okay, so let's look at another experiment right here. You can understand that the body temperature rise is going to cause dramatic change in the fluid distribution. Okay, so if you look at the brain right here, okay, so let me explain. This is the brain, right? And these are the blood from heart. So when you pumping fluid into the brain, so you are passing through, it's delivered by carotid artery. Okay, so in carotid artery, you have two branches. The one branch is right here. It's called external carotid artery. Okay. And this is supplying blood into the face, neck and face. Okay. And you have another called internal carotid artery, and it's delivering blood into the brain. Okay, so you can see two arteries are delivering water into the brain. One is vertebral artery, and another one is internal carotid artery. Okay, so let's look at vertebral and internal carotid artery at 4 different heat conditions. From 1 to 4 means the body temperature increase at different magnitude. Okay. Okay, and you can see that if you increase the body temperature, then you can see vertebral artery and internal carotid artery that supplying the blood into the brain is actually dropping by about 15%. Okay? But if you look at external carotid artery, you can see the blood flow is dramatically elevated. Okay, this is external carotid artery. It's elevating as your core temperature increases. Okay, so that means the skin requires blood, and the priority change, right? So brain are very important, no doubt, right? But you don't want to have your brain cooked by high temperature, right? So that's why you want to dissipate the heat. And in the brain, the major heat loss mechanism is on the skin of your face and the neck, right? And therefore you want to deliver more blood to the skin. Otherwise the brain is cooked. When the brain is cooked at high temperature, you cannot function well. You are going to die, right? So that gives you the priority of the fluid distribution. So that's why I'm saying that the water are the most important topic for sports nutrition, because you don't have enough. If you don't have enough water into your body, then the competition is becoming very serious, right? And who is going to win? Skin is going to win. But when skin cannot win, what would happen? The core body temperature is increasing, and therefore you cannot survive. Because the protein, the enzyme in your metabolic system is going to have the structure change. You cannot survive, right? Because of the malfunction of metabolic system. Okay. So the question is very simple. Why brain becomes second priority under hyperthermia? If you look at this graph, then you fully understand, right? A lot of protein here. And when the temperature increase, the protein structure change, right? So the muscle cannot contract under this condition. Right? Quite obvious. Okay. Then let's talk about exercise, during exercise. So you have two conditions here. The first condition is maximal endurance exercise. So that means you are exercising below 100% VO2 max. Another one is maximal endurance exercise. So we have two conditions. Okay. So let's look at the maximal endurance exercise first. So under this kind of condition, you can exercise for a long time. Okay, so you can exercise for, if you do 70% VO2 max, you can exercise for probably 2 hours. Okay, and under dehydration and hyperthermic condition, the VO2 means how much oxygen you can utilize during exercise. It's going to maintain, okay? And the reason you can maintain is because you are increasing AVO2 difference. What is the AVO2 difference? Arterial and artery oxygen extraction. Okay, so when you deliver oxygen into your leg or into your brain, so they are going to utilize oxygen, right? And you have very little left in vein, right? So artery gives the oxygen and vein has little left, and the difference is called AVO2 difference. It's the indicator on how fast you can extract the oxygen from blood. So that will increase as you are under hypothermia and dehydration condition. But the cardiac output is actually decreasing. Okay. Then may I ask why cardiac output is decreasing under dehydration and hypothermia during prolonged exercise?
Because the heart rate is increasing, but it is becoming less efficient.
Yeah, that's very close. Okay, I will explain that later. What is the main determinant of cardiac output? There are two components. Heart rate and what else? Good. Blood volume and heart rate. So when you choke, then how much blood is injecting away from the heart into your body? So that is we call stroke volume, right? Okay. So one stroke, what is the volume to be delivered out of the heart? Stroke volume times heart rate. Okay, so you you know the heart rate is increasing, right? But the stroke volume is actually decreasing dramatically when you have dehydration. Okay, why stroke volume is decreasing during dehydration under heated condition? Jenny know, right? So when you have prolonged exercise and you feel very hot, the stroke volume is going to be lower, right? Why this is the case? Okay, the stroke volume is going to decrease. It's very important, and that explains cardiac output is strong. We'll talk about that later. Okay, so this is maximal exercise. So this is, everybody know how to measure VO2 max, right? So you know how to measure VO2 max. It's incrementally, the exercise intensity is incrementally increasing to 100% oxygen consumption. Okay, so you have exercise, and the exercise intensity is increasing with time, and the 7 minutes you are reaching closely to your whole body VO2, and this value is called VO2 max, right? So VO2 max represent how fast you can consume oxygen of your body. Okay. How fast of your body can consume oxygen. Okay, and that is the indicator of aerobic fitness during exercise. Okay, so when you are challenged by exercise, how fast the oxygen you can utilize to cope with the challenge. So that is, we normally call it aerobic fitness. Okay, so as you can see, this is maximal exercise at 7 minutes, so you increase your exercise intensity. But if you are under hyperthermia, the core temperature is higher, then you can only exercise for 3.5 minutes, and the intensity cannot further increase, right? So when you feel hot, it's very difficult for you to increase the exercise intensity, and you cannot exercise for a long time. Okay? How about dehydration? Under dehydration, you can still exercise for longer period and higher intensity, but not as high as when you hydrated, right? So from here you understand that hypothermia is quite a big challenge for you. Dehydration would certainly inhibit your exercise potential, but hypothermia is very serious. So these are the conditions. So when you have both, when you are doing prolonged exercise, you have both happen. You have dehydration and hypothermia, and that is seriously affect, and is almost the same as hypothermia, right? So this gives you a very important concept that hypothermia is the real threat when you are doing exercise. So that's why a lot of devices are developed, and a lot of drink, they are designed for the purpose to lower your core body temperature. Okay, and that is important not only for athletes but also for the military. Okay, when you have the combat in the jungle and you you are wearing clothes, you must wear clothes, because if you are in the jungle, there's a lot of things would damage your skin, right? And you have to wear clothes, and that is blocking your heat loss, right? So you have to design those devices. If you are military, you have to design these things. So military, athlete, or you are working in India, Middle East, you have to have certain kind of protection to maintain your body temperature, and therefore you can function well. Okay, let's go back to the question we just asked. Why hypothermia and dehydration is going to lower your stroke volume? Okay, that brings very important physiological principle. It's called Frank-Starling Law of Hot. It's very simple law. This Frank-Starling law is talking about the relationship between the stroke volume and the blood volume of the heart. Okay, so you can take out the heart and you can do experiment by feeding the water into the heart and look at what is the force of the heart during contraction. Okay, so you can do this kind of experiment. Okay, so what Frank-Starling found is, if you have a larger volume of the blood flows into ventricle, so flow into ventricle here, there's a space, okay, then the blood stretch, the cardiac muscle is going to be stretched, okay, and leading to an increase in the force of contraction. So that means, what is the force of the cardiac muscle is depending on how much blood is returning to the ventricle. Okay, we used to call this as preload. Okay, so how much volume of blood is feeding back to the heart, the ventricle, left ventricle, is what we used to call preload. The preload volume is going to decide the cardiac muscle contraction, the force of the cardiac muscle contraction. So if we deliver only small amount of the blood into the heart will stretch like this. But if you deliver more, then it will stretch like this. And therefore, the stroke volume is going to be different depending on how much blood is filling back to your heart. So this is what we call the Frank-Starling law. Okay?
Can I ask you?
Yeah.
So is it similar to straight tripling cycle or the eccentric convection? If you stretch the muscle more, then it will produce more force.
This is a little bit different.
Yeah, it's a little bit.
Right.
Yes.
But if you have the heart, you talk about eccentric contraction, that can happen in heart as well. But that is different topic. Okay, this is different from here. If your heart is contracting, and if the peripheral resistance of the blood vessel is high, then the heart contraction are facing higher resistance. Okay, so if I have the high blood pressure, so I'm the person having high blood pressure, and my heart contraction is going to be different from yours. My heart must contract much more, and I'm going to have a more eccentric contraction in my muscle fiber. Okay, so that explains why some people that has high blood pressure is going to have a bigger heart. So that is something else. Okay. But from here, you want to know that the main reason that during prolonged exercise, when you have hyperthermia and when you have dehydration, okay, then you are going to have a lower stroke volume. It's simply because not enough blood coming back to the heart. Okay, when you don't have enough blood coming back to your heart, the stroke volume is going to be lower. And you have to compensate by increasing your heart rate. It's like this, pump very, very high frequency. Okay. Okay, let's look at here. This is what happened during the incremental exercise for 7 minutes. Okay. If you look at the control condition, okay, this is control condition. Okay, if you look at the red sign here, as you increase exercise intensity, you can see ventilation is increasing, right? So this is quite normal. Okay. Then, if you look at this is BV is blood volume. Okay, if you look at the blood volume, in 7 minutes only decrease slightly. Okay, only decrease slightly. Okay, but if you look at here, this is the VO2 in your leg. Okay, VO2 means the oxygen consumption of your leg. Okay, as you increase the exercise intensity, the VO2 increase. VO2 in the leg increase at the first 3 minutes and start the decline. Okay, you can see that start to decline. And how do you compensate to maintain the VO2? It's by increasing AVO2 difference. Okay, so this is what happens during exercise. So you can see the VO2 in the leg is dropping and the AVO2 difference is increasing to maintain your oxygen consumption of your leg. Okay. And what is the reason that the VO2 in the leg is dropping? If you look at right here, what explains as you increase exercise intensity, the leg oxygen consumption is dropping. Right here, leg blood flow or oxygen delivery to the leg is dropping. And why this is the case? Because of the heat. Okay, that is the main reason. Because the skin requires blood for heat dissipation, and therefore you have to compromise. So the muscles start to get less blood because of the competition. Okay, so that is only 7 minutes incremental exercise in intensity. But if you look at the prolonged exercise means you exercise for 2 hours. Okay, and you have two conditions. for 2-hour exercise, if you don't drink anything, the water in your body will gradually decreasing. So this is called progressive dehydration, right? Okay. And if you can drink, then you can somehow maintain, not completely maintain, but you can maintain your hydration status to a certain degree. So you have two conditions. One is 2-hour exercise, you can drink, okay? And another is 2-hour exercise, you cannot drink, okay? And this is what happened in the blood volume, right here. If you can drink, the blood volume would still drop, right? But if you cannot drink, then the blood volume drops furthermore. And when blood volume drops, the stroke volume change, right? You can see the stroke volume. If you can maintain if you can drink, the stroke volume can be maintained. But if you cannot drink, if you are not allowed to drink, then the stroke volume is dropping. Okay, so then this explains the reason that during prolonged exercise, the cardiac output is gradually declining. Okay, then the heart rate must be increased, right? More during prolonged exercise. Okay, let's look at. So now you fully understand the theory. How is the system in your body is limited by the hypothermia and dehydration during prolonged exercise. And now I would like to show you the real number. The first question is, if you are doing 2-hour exercise at 70% VO2 max, let's say you are cycling from here to Hsinchu for 2 hours, okay? Then what is the most, if you want to choose the right season to do it, okay? If you want to do travel from here to Hsinchu by cycling, so what kind of the temperature you want to choose? In terms of the fatigue, okay, you don't want to have a fatigue, right? So do you want to do it during the summer? Obviously not, right? How about winter? Okay, so let me show you what is the most, the most comfortable temperature, environmental temperature for you to do cycling. Okay, let's look at these numbers are the time that you can sustain. Okay, so at 70% VO2 max, under this exercise intensity, if you are cycling at 4 degrees, only 81 minutes. Okay, to sustain this exercise intensity. For 11 degrees, you can do 93 minutes. Okay, for 21 degrees, slower, right? For 31 degrees, it's even lower, 51 minutes. And the reason is because of the sweat rate. If you increase from 11 to 21 degrees, the sweat rate increase, right? So you are losing water. When you are losing water, your sweating mechanism, your heat loss mechanism is going to be a problem. And that, if you further increase by 10 degrees, then the sweat further elevated, right? So you are losing much more blood, losing much more water from your body, and therefore you can only cycle and you can only do exercise for 51 minutes. Okay. And this is very important for you when you do experiment. Okay? So when you are conducting any exercise in the laboratory, you want to understand 10-degree difference is going to change how long you can exercise, right? So I see we have the treadmill running. Animal is running a treadmill. You have to look at the thermometer. Okay, so if you have a 5-degree difference, and that is ranging from 21 degree to 31 degree, then how fast you can run is the length of the exercise is going to be big difference. Okay, so that is something you want to pay attention. Okay, so what is the answer? What temperature is the best for you to do prolonged exercise? The longest is which one? 11 degree, right? It's not 21 degree. 21 degree is the best for sleeping, right? But not 4 degree. Okay, not 4 degree. The reason is 4 degrees is quite frozen for some people. Okay. And this is the oxygen consumption. What temperature give you the highest oxygen consumption? This is the temperature. Okay, and this is exercise from 15 to 18, 90 minutes. Degree, right? So when the temperature are very cold, then you are consuming oxygen, not only for exercise, but also for coping with the cold environment. And therefore you have the highest oxygen consumption rate. So you're consuming much more energy if you exercise at 4 degrees. But if you exercise at 21 degree and 31 degree, then the oxygen consumption is relatively lower, and you cannot sustain like as long as 11 degree. Okay, so 11 degree is the best temperature for you to do exercise, prolonged exercise. And also the perceived exertion. If you look at 4, 11, and 21, not much different, right? But if you look at 31 degree, then this is from 10 minutes. This is the long 15 minutes. Okay, this is RPE, perceived exertion. Okay, so how hard you feel that during exercise. You feel very difficult, then it's high RPE. Okay, so 31 degree is difficult. 21 degree is slightly higher, right? But from here you can see the first 2 minutes, the first 20 minutes, the lowest is 11 degree. Okay. So this is what you want to know. 11 degree is the best. Okay. Then I would also like to show you if you are dehydrating, how much performance will lose. Okay. If you look at this data, obviously if you have 5% dehydration. How do you measure dehydration? Very simple. By actually the best way is by body weight. acute change of your body weight. And if you are measuring the sweating, is also you can do that. You have to put a cotton here and then put on a scale. Then you can measure how much water get into the cotton for given period of time. So that is.
What's the percentage of the loss of body weight? You say that you are dehydrated. Is there any definition? The percentage of the body weight you lose to become dehydrated.
Okay, this is the scale. You can see. This is the maximal performance, right? And if you have a 5% loss in body weight, then you only preserve 70% of your maximal performance. So it's 30% drop if the body weight by 5%. But if you have only 0.5%, 1%, only 1% dehydration, then you have only 95% of your performance. So you are losing 5% of the performance. It's not big deal if you just do recreational exercise, but if you are doing competition, 5% difference is going to be a big deal. Right? You cannot do well. You cannot break the record. Okay. So now you know that dehydration is detrimental for performance. Okay. Then you want to supplement. You want to have drink, right? So you have two choices. One is pure water, and one is salted water for rehydration. Which one is better for you for rehydration? Yeah. Let's look at the evidence here. Okay. This is an experiment that is dehydrating exercise for how long? For 90 to 100 minutes to lower the body weight by 3%. Okay, this is exercise under heated condition, and therefore you're sweating quite fast. Then you are losing your body weight by 3%. And then you start to drink, and to see how fast your body weight will return back. Okay? Okay, and then you have two drinks. The first drink is water, and the second drink is sodium chloride drink. The concentration of the sodium chloride is about half of the saline. Okay. Then if you look at the consumption, so you are freely taking the drink. Okay. So if you look at, if you are drinking the water containing sodium chloride, you tend to drink more, right? In 3 hours after exercise. Okay, so after dehydrating exercise, if you drink the water that contains sodium chloride, you tend to drink more, right? Because you feel thirsty when you drink salty water, right? And how about urination? If you look at the urination, then which one gives you less urination? This one, right? And this is the water containing sodium chloride. Right, so that end up give you relatively higher rehydration. So if you have the sodium chloride, the rehydration in 3 hours is 82% recovery. If you have the pure water, it only gives you 68% recovery. And the reason is because you tend to drink more if you have the water containing salt and also less urination. Okay, so that is that gives you the idea that the pure water is not the best solution for rehydration. Okay, then you have two choices. One is low sodium and high sodium. Which one is better? If you just look at the urination, then you can know that the low sodium water is going to give you, if you drink 200% of your weight loss. Okay, so let's say you are losing 1 liter and you drink 2 liters of water. That is the white line. Okay, so what is the difference? The sodium concentration 61 and 23. This is half of the saline concentration. Okay, and urination is also 1 liter, 1 ml. If you double the amount that you have lost, if you drink much more, you double. But if you have the low sodium, you're losing much more water because of the urination. Okay, so that sodium help you to keep the water into your body by decreasing your urination. Okay, and that end up has different result in the balance of the water. So this is what happened after exercise, and these are the how much water has been lost. Okay, and you have 4 different choices. One is drinking water with only 50%, so you're losing 1 liter and you drink half liter. It's not going to recover, right? It's not going to recover. Recovery line is right here. The dashed line is the line of your original body weight. Okay, so if you just drink half, it's not going to recover. But if you're losing 1 liter and you drink 1 liter of the water, so that is triangle, right? In 6 hours, it's not going to recover, even you have the high sodium. Right? So you have to drink 150% to maintain your hydration status. Okay, so that means when you lose 1 liter of water, you're going to drink much more. Okay, 2 liter, 1.5 liter, or 2 liter is fine. 2 liter is. The only problem for 2 liter is because you are going to have more urination, and that is not convenient for you as well. So we recommend if you lose 1 liter, you're going to drink 1.5 liter of the water containing salt for rehydration. Okay? So this is only answer the question of how much salt you should provide and what is the volume you should drink. Okay. How about adding other things? How about glucose? Do you want to add glucose into your drink? The answer is yes. And that will even better for recovery in rehydration. Okay, this is urination volume. Okay, so this experiment is very simple. There are 15 men exercise at 70 to 75% heart rate max, and for 90 minutes, and that will reduce your body weight by 2 or 3% due to dehydration. So after dehydration, you are drinking all these kind of 5 different drink. Okay, so you have 5 different drink, and then you start to look at what is the body weight recovery. Okay, the body weight recovery is how fast you can rehydrate yourself acutely. Okay, and all these 5 different drink. Placebo means you don't have glucose. Okay, P and D means placebo with electrolyte. Okay, E means electrolyte. And 3%, 6%, and 12% means the glucose containing drink with electrolyte. Okay, so all these 4 drink has electrolyte and has the glucose. So which drink give you the highest urination? Obviously, placebo, right? Placebo is going to give you more urine. Urine volume is higher than 3 hours later, right? But which one give you the lowest in urine volume? 12%, right? So if you have 12% glucose, the urination is not increased. It's not increased a lot, right? So this gives you the idea that if your drink contain glucose, you are going to have less loss of fluid. So not only the salt, but also glucose. Okay, this is the fluid retention. You can see that there's a quite good linearity if you increase the glucose concentration. Okay, so it's helping you retain water, and that is because of the plasma insulin. Okay. You know, the insulin is going to increase your water retention in kidney, and the reason that the insulin is going to help you to retain water is because the insulin would cause sodium retention in your kidney. Okay, so when you have the insulin, the kidney is running to keep more sodium, and therefore you can keep more water into your plasma. Okay, so you can see the 12% give you the highest insulin spike. So that is the reason. Okay, then that is going to reflect on the plasma volume. Okay, so you can see this is pre-exercise and this is post-exercise. Post-exercise, you are losing water, right? Plasma volume is dropping. And then when you start to drink, you start to bring back the plasma volume if you have more glucose. But you found that the 3%, 6%, and 12%, no difference. Okay, so you don't really need to get 12% of glucose to have your plasma volume return to normal. Okay, so most of the sports drink, they don't use 12%. Okay, so when you have 12%, one thing that you may have is your pancreas is going to work harder to produce insulin, right? So a lot of people, they use 6% instead for making sports drink. Okay, the final question. you know, a lot of people, they train, and after training, they are going to hot bath, right? Okay, why people going to hot bath after training? Because they feel more relaxed, right? The brain is blank. So if you exercise, then you put yourself into the hot environment, then the brain is empty. And why this is the case? Why your brain feel is empty? Why? The reason is because the blood is pouring away from the brain, right? Do you see that? If you increase the temperature, you put yourself into the water that is very hot, and water prevent evaporation of your heat, right? And that is very serious challenge for your body. And therefore you are pouring your blood into your skin a lot, right? And your brain start to feel, brain activity drops, right? And that's why people feel, okay, I feel relaxed. Okay. But is that good for your training adaptation? It's very detrimental. We have done the experiment. And unfortunately, the National Training Center in the South has the hot bath. Okay, we done experiment. It's very simple experiment. We do archery athlete. You know, archery is you have to have the muscle. When you train archery, only specific muscle is require adaptation, right? So this is highly specific. You don't want every single muscle to have the adaptation, because adaptation requires carbon source and nitrogen source. So you only want certain muscle that get the carbon source and nitrogen source, right? So when you do adaptation, you are training yourself every day. You are standing and then you train, right? And the experiment is after training, in 30 minutes, you are going to a hot spring near here. Okay, we have a lot of hot spring here, you know, right? So just go to the hot spring, and then after training, okay, and we do that 2 times a week, only 2 times a week. Okay, post training. Okay, for the control group, also going to the same place, but not into water. Okay, it's right beside the pool. So we have 2 groups. You have 2 conditions. One is after training, sitting into the pool at 40 degrees. And for how long? For 15 plus 15 minutes. And the temperature is 40 degrees. So this is the study design. We have 2 groups, control group and hot group. So they are at the same place, but one is inside the water and one is outside the water. Control is outside the water. And inside the water is 40 degrees, 15 minutes twice. And then we measure the outcome. We measure posture instability. When you stand here, you know, when you stand here, actually you can move. You will automatically swaying, right? You move. And therefore we can measure your stability. If you sway for longer distance, that means your stability is decreasing, right? So swaying distance is the indicator of your posture stability, and that is related to the muscle. Okay, the muscle controlling your posture. And And that is very important for your performance, especially for archery. If you are swaying, then you cannot be very accurate. Okay. And also the muscle as well. The arm muscle and leg muscle are very important. So when we do the experiment, is 2 weeks. So we have 2 weeks. So you are training and recovery under hot bath or under control condition. 2 weeks later, 3 days after the last session of trial, then we start to look at the performance. Okay, this is the performance. Okay, if you look at, this is control condition, and this is the hot bath condition. You can see most of the case has the shooting score dropping on hot condition. So that means after training, you don't want to put yourself into hot spring. It's not very good for your adaptation. Okay, and this is the performance. Control condition, hot condition, it's dropping a lot, not only a little bit, it's dropping a lot, okay? And if you look at the stability of the leg, you can see that under control condition, the swaying is reducing, right? So your stability is good, it's improving by training. Okay, so when you do training, the stability improves. But if you are doing up at hot condition, instability increase. So we are moving a lot. Okay? And let me ask you why this is the case. After training, you put into hot condition and adaptation drops. Why this is the case? You know, adaptation requires what? When you train yourself, right? Only selected muscle in the brain and the leg are recruited, right? So after training, what would happen? The immune system will go into the places that has been challenged, right? And the immune system is delivered by what? By blood, yes, exactly. Okay, so if you are under normal condition after training, then you are recovering, right? And the blood is only getting to the places that has been challenged, right? And therefore you can have adaptation later. But if you put yourself into a very hot condition, what will happen to the blood distribution? Right, it's going to even out for the entire body, right? So the immune system will no longer specific, right? It's not only go to the places that you have challenged, but also it's distracting the resource to the skin or the heat dissipation mechanism, and therefore is bad for adaptation. Okay, so to conclude the lecture today, there are several take-home messages for you. The first, prolonged exercise develops hypothermia, body temperature increase, dehydration, and that is the two main reasons to cause fatigue. Okay, of course the glycogen depletion also plays a role, but the dehydration plays a very important role as well. And the maximal oxygen consumption and endurance performance decrease under dehydration and hyperthermia due to decreases in blood volume and stroke volume. Okay? So the reason that prolonged exercise you cannot persist for longer period, one of the reasons other than glycogen is the blood volume is dropping in your body, and that is going to affect the stroke volume. Heart is going to suffer much more. Okay, the sweating is the main mechanism of cooling to protect your protein structure change in human body. So that is the priority. And therefore, when you have prolonged exercise under heated condition above 21 degrees, then you want to make sure you are well dehydrated. Okay. And when you have the dehydration for 1 liter, how do you measure dehydration? By scale, right? So if you have the acute weight loss, that means you are dehydrating. So if you have 1 liter weight loss, you want to drink 1.5 liter to get full rehydration in 6 hours. Okay? So if the salt concentration is like this. Okay. If you put glucose, that will even accelerate your rehydration because of the insulin action. Okay. 6% is already enough for the plasma volume return in 3 hours. Okay. And the post-training hot bath is detrimental. It's no good for adaptation for highly skilled sports athletes. So if you are highly skilled athlete, you don't want to have the hot bath right after your training. Hydration status matters for survival under exercise stress and heat. So that's why we consider hydration is one of the most important topic of sports nutrition. Okay, we still have 10 minutes for discussion. So if you have question, please.
Could I ask you about hot environment and resistant exercise? How do weight training in hot environment?
Right.
There are some studies seems as beneficial, so I'm thinking what could be the cause?
There are some studies showing beneficial in
hypothermia, in hot environment.
In hot environment?
Yeah, if you train in hot environment.
Okay, I need to see the evidence. I'm not sure about this. Well, for resistance exercise, it's less affected by room temperature. It will be affected, but it's less affected. Okay. As you can see, if you don't exercise, simply hypothermia is going to reduce the blood supply to the brain, right? So you get immediate feeling of fatigue. Simply raise the temperature, right? And therefore you are less likely to challenge yourself. So I think that is the drawback to do resistant exercise. So in my opinion, that although the performance are less likely to be affected in resistant exercise compared with endurance exercise, but I still feel that you should train yourself under cool environment. Yeah, that's my opinion.
Yeah, thank you.
Yeah, my
So
pleasure.
cool environment maybe from 15 to 18.
Core the environment.
Yeah.
I have to say that the data here is for the data here is for endurance, prolonged endurance exercise. But I believe it would apply for the same thing. So if you are organize a gym, you are a manager of the gym, and you are very scientific, then I would say between these, temperature is good. 21 degree you already have decreased endurance performance. But for weight training, I don't know. It's hard to say. Yeah, but this is certainly new topic for you to test. Okay? You can bring very valuable knowledge for everybody.
It was the boss in the gym. I attend to, so I started 3. It's too hot for me.
Yes, here.
In Shilin, nearby Shilin Market. I go to the gym and I always start at 3.
This week is too hot, right? Especially, that's true. Okay. Yes.